In this video, we're going to go over one of the most typical physics problems, the inclined plane problem. Either you have already seen this problem on your homework assignment or you're about to see it on the upcoming quizzes or tests. So although the problem that I will go over is only one of the many variations you can have, the steps that we'll cover will be the same for any inclined plane problem. So keep watching and let's break this down. Here, we need to calculate the acceleration of a 5 kilogram box sliding down an inclined plane, which is tilted at an angle of 30 degrees to the horizontal. Assume the coefficient of friction between the box and the plane is 0.15. So, as always, let's do the first step, which is drawing the free body diagram, right? We have our box that is on the inclined plane right here, and we need to think about what are the forces on this box. So the forces are the following. Of course, there is the force of gravity, which is directly downwards, right? This force is basically always present in all of our problems. mg, that is directly down. We know that this box, right, is at the surface, therefore there will be the normal force, which is the force of resistance from the surface. However, unlike most problems where normal force is up, remember that normal force is actually perpendicular, right? So 90 degrees to the surface. So perpendicular to the normal would be to the surface would be in this direction over here, right? At 90 degrees to the surface. Finally, we have the friction because we're given the coefficient of friction. So the box is sliding down. That means it's accelerating downwards. I also like to label acceleration, by the way, on my diagrams. That means if it's sliding downwards, the friction will always be in the opposite direction of the motion. So over here. So if it's moving down the plane, the friction will be up the plane. Now that we have all of our forces, let's set up our coordinate system. Now, typically to the right and to the left, right, and up and down is what our coordinates, right? To the right, our force is positive. To the left, our force is negative. But notice here, these forces are at an angle then. So what's more convenient and typical is set up our coordinate system like this to consider this horizontal direction and this vertical direction. Notice what happens then. The friction and normal force are already aligned with this new coordinate system. However, the mg force, the gravity, is not, right? It's at the angle. So we have to find the x and the y components. Let's take a look at what the x and the y components of mg are going to be. So mgy and mgx. Now, of course, we need to solve this right triangle, but we're not given any angles in this right triangle. What we're given is this angle right here, theta. So we need to firstly figure out how this angle relates to angles in this triangle. Now, you might have seen this already, but if not, I'll show you a quick derivation of how to do this. So the key when you do this yourself, firstly, is to draw mg all the way down to touch this side, by the way. And we need to look at this angle right here, right? This is 90-degree angle. This is theta. So this will be 90 minus theta, right? Because all angles add up to 180 degrees. So this right here will be 90 minus theta. Now, let's take a look at this small triangle right here, right? This and these are vertical angles. So therefore, this one will also be 90 minus theta. And in this small triangle right here, if this is 90 degrees and this is 90 minus theta, this angle right here is going to be theta. So now, I know this is kind of a lot, and this is a very typical problem. So instead, what I recommend you do, and you will almost never hear me say this, I recommend you either memorize that this is the angle theta, right? Or you memorize the components that we're about to learn over here. So we have this right triangle, mgy and mgx, and we have to solve for the x and the y components of them, right? If we do sine of theta, sine is the opposite side, mgx, over the hypotenuse, mg. And cosine theta will be the adjacent, which is mgy, over the hypotenuse, which is mg. Don't be fooled by the fact that this is kind of like a tilted right triangle, right? Because this is still 90 degrees and this is mg over here. So if we multiply both sides by mg, we get mg cosine theta is the vertical mgy component, and over here mgx is mg sine theta. Now, this problem is so typical that I just recommend you either remember that this is the angle, theta, or remember these components over here. Because as I said, this is a very, very typical problem. So instead of going over all of this derivation over and over again, you might as well just kind of memorize this. So now that we found our components, let's take a look at, let's redraw our free body diagram really quickly. But now, instead of drawing mg, which is our force at an angle, let's just draw its components. As you see, the x component, right, is down the plane. It's basically pushing the box down, and it's equal to mg sine theta. The y component, right, is basically perpendicular to the inclined plane, so it's downwards over here, mg cosine theta, right? Then there is the normal force that is directly up, sorry. And there is the friction force that is in the opposite direction. But of course, it's accelerating, so the friction force should be an arrow that is a little bit lower. And there is the acceleration down. This right here is, I would say, 60% of the problem right here in this free body diagram. Because as we move from our first step, which was drawing our free body diagram and breaking down our forces into x and y components, the second step is going to be to write down F net is equal to ma, so our second Newton's law, in both x and the y direction, right? So in the x direction, the horizontal direction, again, we decided is going to be here. So let's consider down the plane to be positive. So therefore, right, the horizontal forces are going to be these ones. So mg sine theta minus force of friction is equal to ma, right? Because it has that acceleration. Again, you can consider up the plane as negative. That's okay. It's just going to flip your signs, right? So our solution isn't really going to change from changing the system of coordinates. But I assumed down is positive, so mg sine is positive, friction is negative because it's down, and acceleration is positive because it's down the plane. Now, let's do the same thing with the y direction. So these two forces are vertical, right? So what are the forces that are up and down? Normal force, let's consider that one positive, minus mg cosine theta. Of course, there is no acceleration, right, up and down, so therefore a is equal to 0. Or we can rearrange this equation, and n is equal to mg cosine theta. Now, one of the very common steps in these types of problems is writing the formula for the force of friction, which is mu times n. Almost every time when we have friction in our problem, we're going to plug in this formula. And if you don't remember it by heart, you don't have to, right? It's going to be on your formula sheet. You just have to know to look for it. Now, we have a system of two equations, and we have to solve those equations for acceleration. So let's do precisely that. How can we combine these equations? Now, notice the variable that is kind of the same in both of them, right, is n. So what you can do is you can plug in for the normal force over here and rewrite this equation as mg sine theta minus mu. Instead of n, it will be mg cosine theta is equal to ma. Perfect. So guys, we're almost done. So since there's the mass, right, in each of these terms, I'm just going to divide everything by mass, and I have my final expression for acceleration. All that is left is to just plug in the numbers, 9.8, right, and sine of, let me take a look, and sine of 30 degrees minus mu, which was 0.15, times 9.8 times cosine of 30 degrees. If you plug all of that into a calculator, you should get 3.63 meters per second squared. And if you didn't, Probably you messed up somewhere with a parenthesis, or you forgot to put your calculator in the degrees, which you can do by pressing mode on your calculator and going from radians to degrees. So here's how you solve this type of problem, the inclined plane problem. So just to conclude, right, we drew our free body diagram. We found the x and the y component of the gravitational force, which again, as I said, will be always the same for all types of problems. So you can basically memorize this will be mg sine theta and this will be mg cosine theta, right? And whenever you do your homework or on the quiz, from here on out, right, it's pretty simple to solve the rest, because you just have to write out the F net is equal to ma in the x direction, second Newton's law in the y direction, right? Write out what normal force is, plug this in here, and just do few algebraic steps to solve for the acceleration. So guys, I hope this helped. I hope it made sense. Keep practicing and keep watching my videos. Keep practicing more physics problems on your way to an A. Thank you guys for watching.